authority on this. There's a lot of people that have done a lot of great work, both with fire in general in Hawaii and with Ohia specifically. I'd like to just present some of my knowledge today. And with that in mind, we'll get started. I'd also like to thank Hawaii Wildfire and the Pacific Fire Exchange for putting this on. Okay, so when this started out, I had a grand idea to give this big synopsis talk about fire and Ohia, which is a huge, rather complicated subject. So before we get started, I just want to kind of give a little perspective and also let you know what I'll talk about. I'd like to start with, like I said, a little perspective, and then I will go through first just kind of what we know about the pre-human fire regime in Hawaii up through today, and then talk a little bit more broadly about Ohia as a species that's here, and then discuss the relevant research that's been done to date, kind of transition that into what that research means for Ohia in the face of fire, and then finally go over some management considerations. So first of all, just to get started for some perspective, like I said, I started with this grand idea of giving this huge all-encompassing synopsis of fire and Ohia in Hawaii, which was a little naive, perhaps. So I just wanna put the caveat out there that this talk is very Hawaii Island centric and perhaps a little Hawaii Volcanoes centric. That happens to be where a lot of the work, a lot of research has been done on Ohia and fire, and also happens to be where I work. So, everything here is, it just inherently filtered through that frame of reference. So please just keep that in mind as we go along. And that by no means means that we have the monopoly on fire research or fire in Ohia or anything like that. But just inherently, there's a little more of a Hawaii volcanoes or Big Island centric theme to a lot of the data I draw upon. Also, before we get started, I just want to briefly go over a few terms that can sometimes get a little tricky in the fire world and get a little confusing. Just when we're talking about things, for all intents and purposes during the talk today, fire intensity is just the energy released by a fire. Fire severity, the organic matter consumed by a fire, and then where it gets tricky is when we get into these, quote unquote fire effects, which can talk about anything from ecosystem response, which is the general scope of how I'll be talking about it today. Also, fire effects can mean societal impacts, and also, studies on severity or other impacts can sometimes be referred to as fire effects. And in general, I'll probably stay away from those terms today. There's also some other kind of quote unquote loaded words that I'll really try to be careful with today, but I'm going to probably use them nonetheless a few times. Good, bad, positive, negative, that's all contextual. So I want to just, try to, when I'm talking about results, be very intentional about, just talking about the results. And then when I do say, good or bad, positive or negative, that's through the lens of our management priorities and our management actions. Also, I think fire tolerant and fire adapted are really tricky things to talk about and can have some different meanings to some different folks. So I'll always try to qualify that whenever I talk about that. Okay, so with those kind of starters, let's get started looking at fire in Hawaii. First of all, why is this important? So I've just got a graphic of a map of ignitions, of fire ignitions in the state, which was generated by Hawaii Wildfire in the last 50 years. This is not an area burned map or anything like that, just every red dot's an ignition. And the take home here is that there's a lot of fire on the landscape now in Hawaii. And if we have a lot of fire on a landscape and a lot of Ohia on the landscape, inherently they're going to interact at some point. So as researchers, as managers, as people who care about Ohia and other native species, how this significant disturbance regime interacts with one of, or maybe the most important native plant species that we have here, I think is very important. Okay, so what do we know about fire in Hawaii before humans? There's some evidence across the state of fire before people got here. Most of this evidence comes from either bog cores or soil excavations, and although there is scattered evidence from across the state, I would say that on the whole, there is not a great body of evidence and not a very clear picture of the pre-contact fire regime in Hawaii. The fire frequency, how often fire was here before humans is something that's very difficult to characterize, and in my opinion, we don't really have a good handle on based on the available evidence. I think the really important thing and the take-home is that there is evidence of fire on the landscape before humans arrived in Hawaii. There was fire here to some degree before people. Someone once said you can't change the laws of physics. If there's plants and there's ignition sources, there will be fire at some point. And we even see that now. There's over 95% of the fires in Hawaii currently are anthropogenically caused ignitions. However, we still have lava flows. We still have occasional lightning strikes. So we know that fire was on the landscape before people were. What we're really lacking in that, though, is the details. So at this point, it's very hard to make inferences about the frequency and just the overall characteristics of the fire regime before humans. What we do know is that after the Polynesians arrived, the Hawaiians certainly used fire, both for clearing, for kind of a form of slash and burn agriculture, and also to maintain the landscape in different ways. Lowland grasslands were certainly burned for things like pili regeneration, which was used for thatching houses. So the first Westerners, some of the first Western records make note that the lowlands to a very uniform distance from shore were largely cleared, and then afterwards they were, quote, well wooded. So what that tells us is a couple things. One, that is that the Hawaiians were using fire to maintain the landscape, and two is that especially in these lowland areas where that was happening, that's a much murkier picture then of what they were pre-contact or pre-humans, because they were so heavily altered by the time of contact. Okay, so where are we in terms of fire in Hawaii right now? Fire has become a pretty prevalent disturbance on the landscape, especially within the last 50 years. This is a figure taken from Clay Trowernick's publication that came out last year, a lot of fire data that was assembled by Hawaii Wildfire. And the important thing is to just kind of pay attention to the trend within the last 50 years is that it's going up. Kind of a startling statistic that came out of that I was shocked to hear is that as a percentage of our land area, Hawaii actually, 2006 to 2011, we had a greater percentage of land area burned in the state than in 12 what would be considered fire-prone western states. So fire is a very prevalent and has become a very prevalent disturbance on the landscape in Hawaii. So I'll start by making some generalizations about what that means, and then I'll spend the rest of the time discussing why those generalizations don't always work. But typically, when fire here interacts with native vegetation communities, it has negative consequences for those vegetation communities. Negative in the sense of, if you value native vegetation, fire often results in less native vegetation on the landscape in areas that it affects. In general, grass invasions and increased anthropogenic ignitions have fueled this increasingly active fire regime. I'll talk more about that. And as I said, both fire frequency and size have increased in Hawaii, especially within the last 50 years. This trend has become very noticeable. For those things that I just said are typical, we have noticed that there's been some exceptions to this quote-unquote typical behavior, and this will become a theme throughout this talk, the kind of the variability in this system. Some wet forests that are dominated by Ohi'a, some montane areas, koa forests, some native species show levels of what I'll call fire tolerance for now and elaborate on that later. And there's been really variable responses in between communities. So, with that in mind, we'll pause for a second on the fire front and switch over to Ohi'a, which is the other half of this equation in this talk. All right, so Ohi'a, Metrosideros polymorpha, pretty amazing Myrtaceous tree, fairly dominant on the landscape in terms of our remaining native vegetation communities. It's functionally critical. It's the most common tree in most native forests and a lot of remaining native vegetation communities, and has this huge ecological range. Coast to tree line, huge temperature range, the wettest areas to some of the driest areas, and as a primary colonizer on new lava flows on the Big Island all the way to these 4+ million-year-old substrates on Kauai. So Ohi'a just really has this huge range. To illustrate that, this is taken from John Price and others. Their ecological range maps, or some people would maybe refer to this as a climate envelope. And as you can see, in terms of just their ecological tolerances, Ohi'a can be found almost anywhere in Hawaii. That's a good portion of the state. That doesn't mean it is found everywhere or it was found everywhere. The record is murky on some of that. But then we go into what is probably the more important half of this equation, is what the current extent of Ohi'a is in the state. This is kind of a rough picture. This is taken from the Hawaii gap analysis data and shows within reason the current extent of Ohi'a in the state. It's over 1 million acres and represents a huge portion of our state's remaining intact, or to some degree intact, native vegetation communities. So as I said earlier, we have fire, this disturbance, which is really prevalent on the landscape, and then we have Ohi'a, which is this amazingly kind of plastic organism in terms of its ecological range, and is a really important component of our watersheds, our native vegetation communities. So how these two interact is really important for the future of our native vegetation communities. With that in mind, here are some important questions related to fire and Ohi'a. Scientists and managers are currently aware that fire is a pretty destructive disturbance in the near term in Hawaii, as it is most other places. But then ultimately, do these effects persist over time? Do these destructive effects last 50 years? Do they last 100 years? What's our time scale here? Are fire effects consistent across different vegetation communities and different environments? Does a mesic forest or a seasonally dry woodland respond to fire the same way as a wet forest does? And then on kind of to that end, are biotic and abiotic variables important to post-fire community response? Does substrate matter? Does rainfall matter? Does elevation matter? Does ungulate density matter? Does a number of other environmental variables matter? Well, there's been a lot of good data gathered, both related to fire and Ohi'a and the interaction of the two in Hawaii. We have good data on grass fire cycles, on individual species response, on both the short-term and medium-term community response to fire, on the effects of a single fire across a gradient, and also on the effects of multiple fires. So I'll kind of go through some of those now. All right, first off, this what we call the grass fire cycle here. There's a paper that came out in 1992, D'Antonio and Vitusic, that kind of detailed this cycle, and there's been a lot of other great work on this done. More recently, Lisa Ellsworth with guinea grass on Oahu. And essentially, this is a very simple idea that these fire-loving alien grasses have invaded, that these grasses like fire, they promote fire, and then the fire in turn promotes these grasses, so you get into this self-reinforcing cycle. This is one of the big drivers of our increased both fire frequency and fire size. You know, these grasses put fire on the landscape more, and they put it into bigger areas on the landscape. And that's the really important part of this in terms of Ohia. You know, you might be saying, okay, well, what does fountain grass burning have to do with Ohia? And, you know, if to make a really bad analogy, you know, if you have gateway drugs, you can think about these grasses as like a gateway fuel. You know, the grasses themselves burning is not really important, but these grasses a lot of times can get fire into these Ohia systems. You know, as an example, on Hawaii Island, we had a lot of natural fuel breaks and naturally discontinuous fuels on account of the fact of all the young substrate that we have here. We had a lot of bare lava flows that acted as fuel breaks and acted as, you know, kind of these areas of discontinuous fuel. Well, when fountain grass comes in and invades and, you know, densely covers some of these sparse flows instead of discontinuous fuels, you know, where if you do get a start, you might have a 1 acre fire. Now you have these wonderfully continuous thick fuels that run all the way up the mountain to your next closest stand of Ohia. And then the fire, you know, that's the way that the grasses and the grass fire cycle gets fire into more of these areas that still have native species in them, and that's why it's pretty destructive. Okay, so when fire does get into these native vegetation communities and the Ohia communities, you know, what happens? What does fire in the immediate term do to these communities? You know, in general, it's a pretty drastic disturbance. It's pretty destructive. That can be said of fire pretty much anywhere. You know, that's what fire does as a disturbance. In general, here, and once again, this is all just generally, Ohia is pretty sensitive. So nearly all Ohia are generally top killed in a fire. As with a lot of other areas, when you have a fire come through, there's usually a drastic reduction in community biomass. And then here, that's often followed by a large increase immediately after the fire of non-native 1 hour fuels, also known as alien grasses and forbs. What we do see with Ohia in the near term, immediately after fire, is that even though most or nearly all, and by nearly all I mean, you know, generally 90-95+% of Ohia are top killed, we do see some epicormic resprouting, and to a lesser degree, but then also to a greater degree, some basal resprouting. You know, we see areas where you could have 95+% of Ohia top killed, but half of those, or more than half of those, might resprout basally. Okay, so if that's what happens immediately after fire, you know, what's going on a little longer scale? What's going on the order of decades? And this is where things start to become a lot more complicated. And in this case, we start to seem to get a lot of divergence between different study sites. So Ohia especially, and a lot of other native species, are generally slow to recover, if they recover at all. This time frame, you know, of decades for for community response, there's not a lot of data, but I will here do some shameless self-promotion and mention my master's thesis, where I looked at 14 sites across Hawaii Island, and one thing I found was there were variable responses across those 14 sites in very different habitats, all with an Ohia component, but that in none of those sites had Ohia or native vegetation in general return to its pre-fire density and especially structure. So that's generally agreeable with the other small amount of data that we have for fire response in Hawaii, on the order of 30, 40 plus years. There was a single study in kind of a seasonally dry woodland 5 years ago by D'Antonio that also agreed with this, that after 37 years, Kipukenene had still not recovered to its pre-fire density or structure. So this is kind of starting to paint a picture of these, it's a complicated picture. These sites, we get divergence between sites, and we get variable responses, but in the grand scheme of things, at least on the order of decades, you're not generally going to see in these systems that are dominated by Ohia a return to pre-fire conditions on the order of decades. And then ultimately, the ultimate question for that becomes, okay, well, have they just not had enough time, or are they not going there at all ever again? And that's what we're going to talk about more. In terms of individual species response to fire, I mentioned that Ohia is generally top killed, and then there are some basal resprouts. There's a couple tricky things about that. One is whether those basal resprouts persist, and there's not a lot of good data on that. There's some great 1 or 2 year post-fire data that that has documented over 50% of individuals that were top killed resprouted basally for Ohia. But then, we don't have those trees tracked over 10, 15, 20, 30 years. And then on the flip side of that, there is also, I would say in general, a lack of seedling recruitment of Ohia post-fire, and that's very poorly understood. Ohia is inherently a disturbance-adapted species. It's a primary colonizer. The seedlings generally need light. You kind of have this, even something like cohort senescence, where you don't really get the next pulse of and the next generation coming in until the previous generation dies. So with that in mind, it seems like Ohia should be a little more receptive to the post-fire environment. Just kind of inherently seems like it would be a little more conducive to seedling recruitment for Ohia. And in general, there's just not, at least in a lot of the research that's been done here, there's not a lot of seedlings and a lot of seedling recruitment post-fire, and we don't understand why. And that'll come up as a research need later. In terms of other individual species response of some other native species that make up these communities, there's this, I think, this kind of overarching wisdom that, there's no fire in Hawaii, and no Hawaiian species are adapted to fire or tolerant of fire. And that's a really tricky question that I won't totally claim to answer today by any means. There are some native species, it's important to point out, there are some native species that show what we're going to call the fire tolerant traits. And once again, fire tolerant is kind of this complex, loaded word, which we could spend a whole other webinar discussing. But just broadly in general, when you talk about fire tolerance or fire adaptation, for plants to be able to deal with fire on a landscape, they either need to, there's kind of two main ways to do that. You can either survive the fire, or you can come back in after the fire as a plant. So, fire tolerance could be interpreted a number of different ways. It could be the ability to resprout and regrow after fire through basal or epicormic sprouting, or it could also just be the ability to colonize very well and be competitive in the post-fire environment. So there's a number of different ways to kind of, pardon the metaphor, skin a cat in terms of fire tolerance. And just as an illustration, I have thrown up a list from some work that was done at Hawaii Volcanoes close to 10 years ago now, and just a list of species that was identified as fire tolerant. And in this case, fire tolerant meant the seeds were tolerant of heating and would germinate following heating. So that's one way, but then it's by no means an inclusive list. There's other native species that show fire tolerance in other different ways. Koa, for example, Acacia koa, is a fantastic at suckering. And after a fire, both via seed and via suckering, koa typically comes back on the landscape very well. You also have something like Subodium tree ferns, which are going to be illustrated in this next slide. Just because of their physiology, they're very well insulated from heat. And this is one of the few native species where we see this come back after a fire almost as well or better. You can't see well in this bigger photo, but I'll try to zoom it in a little bit here. Every one of those little green circles with a shadow under it is a tree fern in this big burned area in the east drift zone of Hawaii volcanoes. So, some, that I don't think it's fair to make the overall statement that Hawaiian species in general aren't ever fire adapted or fire tolerant and just can't ever deal with it. We do see these instances in these species where they show particular traits, whether it's being able to survive the fire or being able to have some heat tolerance or germinate in the post-fire environment, that would be seen as encouraging. It's just once again, this is a complicated situation, and sometimes that's encouraging, but then taken in the whole of what's going on is much more important. Okay, some more on what we know as far as fire and Ohi'a go. There's been, to a limited degree, effects of fire across an ecological gradient. So one of the kind of cool things about Ohi'a is that it does occur across such a wide ecological gradient. And in this case, we can have fires in multiple vegetation communities with Ohi'a that are still very different from one another, other than they have the commonality that they contain Ohi'a. Otherwise, they're very ecologically and perhaps functionally, but certainly environmentally different. So there's been a few opportunities where a fire has burned through multiple vegetation communities, and specifically Ali Ainsworth and Boone Kaufman published a paper in 2010 where there was a nice, a fire that went through a nice gradient of about 5 different vegetation communities in an area where there's a pretty sharp gradient, and these communities all, to some degree, had some Ohi'a. From the limited data that's out there, when fire burns across a gradient, the post-fire response in some cases has been tied to the certain biotic or abiotic variables. In the Ainsworth and Kaufman paper I mentioned, they found that fire, that native species response following fire was better in wetter areas, but then those wetter areas also happen to be higher elevation areas and also happen to be less invaded areas. So with all these biotic and abiotic variables that we're trying to figure out their influence on community response post-fire, it's always really difficult to parse individual variable effects out from the noise. I'll also mention that there was another study done by Carla D'Antonio and some others about 15 years ago where they looked across a a suite of these what we call kind of seasonal Ohia woodlands where they're seasonally dry. But they looked across, a number of these communities with slightly different elevation, rainfall levels, and a few other things, and found that the presence of certain invasive species, or particularly the presence of molasses grass, Molinus minutaflora, really influenced how things recovered. So this goes back to some of these biotic and abiotic variables are likely exerting an influence on how communities respond post-fire. It's just very difficult to separate these effects from all the noise because there's so much going on. Okay, and then also we know to some degree the effects of multiple fires. In terms of from an Ohia standpoint and from a native species standpoint, what we would call these negative effects. The effects of multiple fires are cumulative. What we see, what's been seen from the research that has been done is that each successive fire really is just a kind of a further disappearance of these things from the landscape. I've got a photo up here from a fire, once again in the east drift zone of Hawaii Volcanoes. On the left, you've got a one-time burned area, burned 8 years ago. You can see the larger Ohias died, but you do have some either basal resprouts or a new cohort of seedlings, probably basal resprouts coming back, and a few other native shrubs, and then also a nice bed of sword ferns that came in. And on the right, you have an area that burned, that was also this burned 8 years ago and then burned a week ago. Any new Ohias that have managed to survive via basal resprouting, or our seedlings are dead, as are the native shrubs that have come up. So what you will probably see in this twice burned area is in 8 years just a bed of sword ferns. So really these cumulative effects of multiple fires, in terms of from a native species standpoint, often seem to just lead to a further disappearance of these organisms from the landscape, and this certainly seems to hold true with Ohia. Okay, so to revisit those original questions I asked, and just in terms of what's going on and those overarching questions with fire and Ohia and native vegetation communities interacting on the landscape, what is going on? I am going to throw in the ultimate punt here, which I think is applicable, and say it's really complicated. There's a lot going on here. Fire in itself is complicated. You have, fires, no two fires are equal. A fire may have different intensity, may have different severity, may have different residence time. It never, no two fires are ever going to burn a completely similar patch of forest or of woodland. You have different biotic and abiotic variables. Each community might have a different density or structure. Also, we'll have different substrate, different rainfall levels, different ungulate densities, and there's just, there's only so many things you can hold constant. Ohia is pretty phenomenal that it occurs on such a huge range across the landscape. But then in this case, that also presents problems because in the range that Ohia occurs in, the biotic and abiotic variables vary so widely that it's really hard to get a handle on things. But that doesn't mean we can't try. So to revisit these questions, for the first question, do these effects do what is seen as a dramatic reduction in native species post-fire, immediately post-fire? Does that persist over time? As I discussed earlier, in the 50-year time span, it seems like, yes, that those effects do persist. We have not, the body of research that's been done largely has not seen an Ohia system recover to a pre-fire structure and density within 50 years. Now, over 100 years, At this point, we don't know. There's nothing. We don't really have any research on that time frame. Are these effects consistent across different communities and environments? No, they don't seem to be. There seems to be a lot of divergence in community response, and even in response within similar communities. So that's something that could use a lot more work, and there's need to get a handle on. Finally, are biotic or abiotic variables important to post-fire community response? Yeah, we think so, absolutely. Just separating out what everything is doing is sometimes difficult. Okay, I just want to highlight, to try to highlight the point I'm making about these variable responses, I want to show a few examples. First of all, in wet forest, this is 3 areas of wet forest in the East Rift Zone of Hawaii volcanoes. On the left, we have an area with 3,500 millimeters of rainfall a year, almost 800 meters of elevation, uninvaded, and burned in 2003. This area, 10 years later looked pretty good. There's a nice cohort of native plants coming back, including a nice cohort of Ohi'a. Just a couple kilometers down the burn, you have a slightly drier area, 2,800 millimeters of rainfall, just a little bit lower, and it was also invaded a little bit before it burned. In this area, you have a scattered component of native trees and some tree ferns, but then it's largely, the understory is now largely dominated by non-native grasses and forbs. So pretty variable response in just a couple kilometers there, in somewhat similar environments. And then on the right, just to throw a total wild card in, you have, once again, that kind of same group of burns. You have an even slightly drier area, 2,500 millimeters of rain a year, and it was uninvaded, but it had a lot of cinder. The recovery there has been largely native, but it may have reverted to some sort of pioneer community with all the cinder, and that's a community that Ohi'a and other things are largely competitive in. So, lots of different things going on here. In the seasonal woodlands, on the left, we've got an area close to the Mauna Loa Strip Road of Hawaii Volcanoes National Park, 1,200 meters of elevation, about 1,900 millimeters of rainfall a year. This burned in 2000. There's a nice cohort of Ohi'a coming back, mostly basil sprouting, a few seedlings popping up, and there's also a component of native shrubs after 10 to 15 years. On the right, we have what we'd call kind of a worst case scenario, where we have an area, Kipukanene, little lower down, 850 millimeters of elevation, similar rainfall, that burned in 1970. There is not Ohi'a regeneration there, and to a large degree there's not native shrubs there. What do we have that's different between these two sites other than the elevation? On the right, we have a pretty heavy presence of this grass, Malinus minutaflora, that covers everything. And in the sedge area, we don't have that. There's bunch grasses in this area. There's still microsites available. So, just looking on these two examples, you would think, okay, well, maybe in that case, that's the presence of that species that's driving response. And that may be the case. It's just, you can't replicate, or you can't draw that conclusion with a sample size of 1. So, replication a lot of times, too, is just very hard in terms of trying to get an idea of what's going on. Just to further pound the point home, we have two kind of similar sites which are dry but kind of foggy montane sites at 1,700 meters of elevation, 600 something millimeters of rainfall. The site on the left burned in 92, the site on the right burned in 94, and the site on the left has a decent cohort of Ohi'a coming back, but had koa before. It doesn't have any koa now. Well, the site on the right has not as much Ohi'a, but has a nice cohort of koa coming in. What's different? Well, you talk to the guy who ran the dozer on the fire on the left, and he'll say, yeah, was a great cohort of koa that came up right after that fire, and then the goats ate them all. So, ungulates then are just another example of one of these variables that can really affect, seems to really affect community response, but we can't totally get a handle on, How? Because we can't replicate it enough. Okay, so also important to put into perspective that Ohia recovery is a pretty slow process. This is kind of a landscape level photograph of this large burn complex in the East Rift Zone of Hawaii Volcanoes National Park. And this burned area, which is kind of at the bottom of your screen and on the right, is a lot of that area is what we would consider one of the better native species responses following fire that we've seen. But that's obviously not back to its pre-fire state. And it's, I hear the voice in the back of your head which says, oh, well, of course not. You're not going to have a slow-growing hardwood closed canopy forest recover after 10 years. Agreed. It's just important to keep in mind that recovery is a slow process, but also, is this recovery time for species invasions, time for climate change, time for other things? Just to zoom in a little bit on that, what we would call like our best case response in terms of native species recovery. This is in wet forest, about 3,500 millimeters a year in a site that was fairly uninvaded before fire. 10 years post-fire, and these values are relative to an unburned control nearby. We saw a 72% recovery of native cover, a 42% recovery of Ohia cover, but then you only have a 12% recovery of basal area, which you would expect to be slow. The thing to keep in mind I mentioned, ultimate question here is, is that recovery time still time for your system to become invaded, for climate change, for ungulates to come eat everything? Is that a period where you're going to have continued recovery, or you're going to have some other perturbation to the system, whether that is a second fire or something else? And then when you get that worst case, and this is once again, I said I wasn't going to use good, bad, I used ugly instead, and this is subjective, but from a standpoint of native species on the landscape, the worst case is ugly. This is Kipukanene. This is a seasonally dry woodland that was formerly large scattered ohia with native shrubs. The understory was invaded by alien grasses in the 60s. It burned in 1970. And there's been a couple different studies here that 37 and 45 years post-fire, there's not a recovery of ohia, and there's largely not a recovery of native shrubs. So getting at, you have these systems where, we just looked at a system where it burned, and it looks like, oh, we may have a recovery, of native species going on. Then we have these other systems where they burn, and they don't seem to recover. So what's happening overall? Well, to date, there have been no burned at the time scale that research has looked at. There's been no burned ohia-dominated sites have recovered to pre-fire vegetation structure and density. Biotic and abiotic variables seem to matter and are important to vegetation response, but it's hard to separate those variables from the noise. There's lots of subtle site differences that throw even more noise into the system. So where are these sites headed, and can we explain why? With that, this came out of my thesis. I kind of proposed this conceptual framework of, we have this matrix of, on the x-axis, you have anything from a native and ohia-dominated community to somewhere in the middle, you have this community that still might have a native and ohia component but is invaded, and then on the far right of the spectrum you have a totally alien community. As time goes on and you have fires, what it seems like what is generally seen is that the best case is that these systems stay the course, the fire comes in, disturbs, and then they recover, and that recovery may take a while, but the worst case is that these systems, once fire comes in, they move further to the right along the line. They move from being, native dominated, Ohi'a dominated, to invaded, and to alien. And I'll throw in the caveat that in these systems where fire is happening, we don't know if it's just the fire or if it's the species invasion would have happened anyway, but fire seems to at the very least accelerate the process. What we don't really see here without active management, and even some cases then not really, is things moving back to the left along the continuum. We don't see alien dominated communities burn and then magically turn into native communities. That's not happening. So that's pretty important, I think, is that our best case situation here, fire, as in other places here, is a stand altering event for Metrosideros community, for Ohi'a communities. Your best case scenario is a slow recovery, but your worst case scenario is no recovery at all and conversion to a completely alien community. With that in mind, I'd like to kind of quickly, because I'm going long here, I apologize, talk about some management considerations. And it's very important to note, the mission of the National Park Service is to, part of the mission of the National Park Service from a natural resource standpoint is to preserve ecosystems, ecosystem processes, and also to preserve and protect these native species on the landscape. And everyone's management considerations will be different based on their organizational values and organizational goals. But with those values and goals that we have for the Park Service, and which I would imagine some people in this room or listening to the webinar probably share, we have these management considerations which include, aggressive suppression of fire in Ohi'a systems, fuels management, targeted weed control post-fire, establishment of fire-tolerant native species, monitoring what's going on, and then also really having this management plan in place ahead of time. And I'll talk some more about these things in a little more detail. For suppression and fuels management, by we, I mean the Park Service here aggressively suppresses fire in Ohi'a systems with the goal that we're, want to preserve these Ohi'a systems, as I show a picture of, lava running over one of our fuel breaks, but you do what you can, and sometimes you have to readapt. We also have identified fuels priorities in Hawaii Volcanoes National Park. The fuels priority is fountain grass. It's been actively and aggressively managed on the better part of 25-30 years now, and the danger with that as a fuels from a fuels management standpoint is, as I mentioned earlier, just the ability of fountain grass to totally change the fuels continuity and to get fire into some of these areas where it couldn't, it would never have carried to before fountain grass. We also want to identify high value areas. We know we don't have enough resources to manage everything. What are our priorities? I've just put up an example of a map of critical habitats for plants. For us from a management standpoint, it might be more special ecological areas. And once again, it'll just depend more on management objectives. Fuels are really, really, really important. I talked about fuels already and fountain grass. I've shown an example of guinea grass prescribed burn on Oahu, which is kind of ripping in some pretty calm conditions. Well, what does that have to do with us at Hawaii Volcanoes? We don't have guinea grass on the landscape yet, but it's popping up and we don't want it here. So this is also one of those that is a game changer in terms of fuel loading and potential fire behavior and how it would affect those things. So once again, guinea grass is actively suppressed and managed when it pops up here. We think also that targeted post-fire weed suppression is very important, and Morella faya would be the best example I can give here. Identifying problematic species, but then hitting them early and hitting them often post-fire. You may have one beneficial thing from a weed management standpoint is that fire may take your density of certain species down to levels that they're manageable. And if you hit them right away, you can keep them at a manageable level. This photo, we have our treatment line, and on the right, there's not really any FIA. On the left, there is. And if we don't treat that, we get a landscape full of FIA. So there have been some recoveries that have been maybe facilitated or at least helped by, not necessarily these species that are altering the fire regime, but that we know disrupt native communities, and if you can keep them down after a fire, that's a good chance to do so. Also, and this is more experimental, but the establishment of fire-tolerant native species, identifying native species that are specific to the area, and then these experimental treatments that may involve an altered suite of species on the landscape. But if we think that there's going to be fire on the landscape every 10, 20, 30 years, and we don't think that Ohi'a can handle that, we may have to move to an altered suite of native species that we think can handle that. If you want to do that, one real big problem is just material. You want to have material stored and ready to go so you can put it out on the landscape and take advantage of that, what is maybe a sweet window post-fire. And then I think this is just more of a general management adage in general, but prioritize limited resources. Everyone has never enough time and money. As a resource manager, it's often crisis management, it's prioritizing management actions, and maybe not spending a lot of time on things like koa or a'ali'i that are going to take care of themselves. There's also some shortcuts in terms of, if you can get away with direct seeding versus planting and picking your battles. So I think on the whole, managing Ohi'a-dominated vegetation communities in a future with more frequent and bigger fires is challenging, but that doesn't mean it's impossible, and that doesn't mean that management actions and research doesn't make a difference. It does. They both do. Important decisions can be made. We can minimize the loss of Ohi'a to communities to fire, and we can maximize the benefits to Ohi'a and other native vegetation from our management actions. With that in mind, sound management always relies on sound research, and there's some areas where there's a lot of research needs. More long-term data is needed. 40, 45 years is kind of the top end of what's been looked at. It'd be great to track a fire for 100 years and across generations. I mentioned earlier Ohi'a seedlings. Why are there no Ohi'a seedlings in the post-fire environment? They're not seed limited. They're good germinators. They seem to be disturbance adapted. What's going on, at least from a seedling and germination standpoint. More studies outside of Hawaii volcanoes in the Big Island. That doesn't mean there haven't been some good stuff done. There's been some great stuff done on Oahu and some other places, but in general, that's where a lot of the research lies, and it'd be great to get more other places. Also a lack of what I would call just basic fire stuffs here. A fuel model for sword fern, a fuel model for uluhe, a better data on fire intensity, which is really hard to get at. Also testing more species for fire tolerance and altered communities as this altered native suite of species as an experiment. If there's any grad students listening to this talk, there's lots to do or lots of potential. Also, just communication and outreach. There's great things going on in that channel right now. Especially really want to point out, Pacific Fire Exchange, who put this on, and Hawaii Wildfire Management Organization. We don't have Smokey the Bear. We have Kaleo the Pueo in Hawaii, which is awesome. I think in general, there's great channels of communication open. The research scientists, the land managers, outreach professionals all talk here really well. I wanted to, I was going to put the logos of all the folks who are involved in fire management or research or outreach in Hawaii, and I almost ran out of room on the slide. It's a great list of people, so I think keeping those lines of communication and outreach open is critical. I need to thank a ton of people. I'm going to miss somebody. Becky, Carla, and JP on my thesis, at Hawaii Volcanoes, everybody at NRM Rhonda, Sierra, Ali Ainsworth, David Benitez, and then also with the general NPS fire program, especially Nelson Siefkin and Robin Wills for making a lot of these fire programs happen. And then just a ton of folks who are doing great research otherwise on fire in Hawaii. Just off the top of my head comes to mind Creighton, Susan Cordell, Lisa Ellsworth, Kealoha, Flint Hughes, Carla D'Antonio. I know I'm going to miss some people. And then just everybody who's helped with any of these studies along the way. So with that, I am going to shamelessly put a picture of myself up as a thank you slide. And then I talked longer than I thought I would. I apologize, but maybe there's questions and we can have a little time for a discussion here.
This is Melissa. Thank you so much, Mark. I really got a lot out of that. For folks, if you have a question or comment, you can enter something in the chat window. You can raise your hand. And I believe everyone should have microphone rights. There's a little button, should be down towards the lower left of your screen. You can hold it down and talk. But maybe for the purpose of managing the question so we're not all talking at once, if you could raise your hand or enter something in the chat box, and we'll just go through the list and acknowledge each indicated question.
Okay, so it looks like a question from Jeff to start us off here about historical records on the windward side of the Big Island in the late 1800s or early 1900s. I'm going to some degree punt that question, Jeff. That might be more of a question for Clay or some of the folks at Hawaii Wildfire. Personally, when I was looking through records, there are from that time period is there are these anecdotal or these brief accounts from a personal interview or otherwise. What is really hard to pin down with those is any sort of a specific area. You might have I don't know, like just to throw something out there, you might have a record of fire above Cane Land, Ninole, and that's it. And then so in terms of getting at some quality data in terms of research and learning more about long-term response, those early accounts are not great in terms of being able to define a specific area, but in terms of are there records on the windward side of the Big Island in the late 1800s, early 1900s? Yes, I believe there are a few, but I'd certainly defer to Hawaii Wildfire or some of those folks that have done a lot better aggregating of that data.
This is Melissa, and I don't know specifically. I know that recently Clay put out a blog post on a fire on the Hamakua coast, which led to the formation of our forest reserve system in the state. But I guess the question that comes to my mind is, even though, as you said, we might know that there was a fire, we might not know the exact conditions of the forest before the fire. Though it might be interesting if you could get a sense of the conditions now, given the general known location of it.
Yeah, I agree. As we get into the further kind of in general, the further down you get into these lowland areas, you get into systems that are just historically more disturbed and have a longer history of land use that we sometimes know and we sometimes don't know. But once again, that's just more noise in the system. And if we're trying to, or if you're trying to get a handle on vegetation response, one important thing is, both, well, where was the fire, obviously, but also just that post-fire environment, and that, that's hard in areas where there are poor records and you don't have a good idea of what was happening in the post-fire environment. Okay, so I will go to a question from Steve. What are your thoughts regarding fire and poorly developed soils at Pohakuloa? We have a high undecomposed organic matter that tends to burn during a fire, leaving mostly ash. Okay, so that's an interesting question, Steve. And that applies to also at Hawaii Volcanoes. We have, a fair amount of also poorly developed soils would be a nice way to put it. I would first acknowledge that there's some great work by Kealoha Kinney and some other folks that happened at PTA just in terms of, the general successional trajectory of these communities over time with fire in that system, which they found. This once again, I think maybe gets at, I'll just maybe speak to it from a perspective of what are the effects for Ohia and kind of maybe native systems and as well. These poorly developed soils, we would expect to, Ohia to do well in those places. So that's one of those, I think is very poorly understood. Ash, if you have, I haven't seen too much fire up in your neck of the woods, but ash, ash tends to be a great, a great starter for things. You can get great soil development from ash if it doesn't all blow away. So I think that is a complex question. You also have a lot of, at PTA, I would say another thing that could potentially be thrown in the mix is you have probably some Eragrostis species that, especially before the arrival of fountain grass, are actually fairly competitive in the post-fire environment and do fairly well. So once again, I think this is like this whole host of, it almost just brings up more questions in terms of, okay, well, we have fire, we have these kind of poorly developed soils that are either pioneer communities or just poorly developed for other reasons. We have these suites of organisms that we think should be competitive in that environment, and what is, what is happening if we have fire in these systems now? Why are things not competitive? And do you have a situation where where you have fire that's coming through, and you have either this whole host of invasive species that's coming in either via roots or four hooves, that's really changing the game. Once again, with all these questions, I want, we want more data points. So I don't know if I really answered that question, sorry, but I'm gonna go on to a different one. I think in conclusion with that, with just fire and poorly developed soils, you have what is kind of a reduced suite of species anyway. We've actually seen in some places here with poorly developed soils, we've seen some better response just because those underdeveloped soils, and especially those pioneer communities, Ohia and some other native species, are actually decently competitive. But Pohakuloa, different elevation, different rainfall, different suite of species. One of those seems to be one of those pretty context-specific things. Next question would be from Forest Solutions. Management implications keep fire out. In general, yes, I would agree with that, and we would agree with that. Have you seen anything positive post-fire that you can capitalize on for restoration efforts? I would say absolutely. We've seen things positive post-fire that we can capitalize on. One thing is just that you do have, I think time is one of the most, from a management standpoint, time is one of the most critical things. You have, it's variable, but you would have, potentially this pretty sweet window up to maybe even 6 months post-fire, where, you have this nice, you have a lot of light, you have a lot of microsites that are available for seeding or planting and recruitment. And you also have a low density of competition at that point, or you don't have a 5-foot mat of kikuyu or malinus or something, keeping out everything else. So, I would even frame this in the kind of the in a greater context of sometimes the things that are, the species that are successful might just be the species that get there first. If you want to talk about island evolution and ecosystem development in a greater context, then I think, just parsing that down to a much smaller scale for our restoration context, in terms of ways to capitalize on restoration efforts, we feel like if we can get our species in there first and those native species in there first, that's how we can really capitalize, and that's a way that we can get them into the landscape and they can persist on the landscape. Unfortunately, that's really hard with Ohia, just because it's so slow. Both with which kind of all phases of its growth process. And I really would emphasize again that is just something that, at least here, we don't understand well. We just generally do not see a lot of Ohia seedlings on the landscape post-fire, and that is poorly understood. So yes, I think in terms of capitalizing on restoration efforts, getting things in quickly after fire, and that speaks to, having a plan in place, having material. We have 4 freezers full of seeds that are just all they're doing is going out post-fire. I also talked about it in the talk, but I think that is a time where you maybe have some invasive species or some alien plants that are reduced to a density where you can actually manage them. And if you're aggressive immediately, you can keep them at manageable levels, and allow your restoration or your response to proceed more favorably. Any questions from any other folks? All right, well, I would say if nobody else has any questions, I would just once again like to thank Pacific Fire Exchange and Hawaii Wildfire for putting the webinar on. My email is up on the screen too, so if anybody has any questions, anything they want to discuss, it's always great to hear what other folks are doing. And just I'd also like to again acknowledge all the other people that are doing amazing work with fire in Hawaii. I know I probably slighted somebody or missed somebody, and there's a lot of other great research going on. And I think just going forward, hopefully the outreach folks, the managers, the researchers, everybody, we just keep talking. And I think that's there's a lot of good lessons learned from every fire we have and every restoration effort we have, and how we approach that. So thank you very much, everybody.
Thank you so much, Mark, for your time today. Thank you, everyone, for attending. I have a SurveyMonkey link in the chat window. We'd really appreciate it. And I think Mark would also appreciate it if you could give us some feedback on how you think things went today and the value of the information that you got through the webinar. So thanks again to Mark, and thanks to everyone for attending. All right, so I'm going to close the webinar now. You should see it all shut down. Thank you once again, and please do fill out that survey.